Hey students, this is the video notes for section 7.2. These are called the proportionality theorems, and there are 3 of them. The neat thing about all 3 of these formulas is you're going to see me talking about this, and it's the same formula every single time. So as long as you follow what I'm telling you as far as how to set up the problem, the work is going to be pretty easy for you. Okay, so in the first theorem that we have, it's called the triangle proportionality theorem. We like to call it the side splitter theorem because the sides are split and we use the little pieces. So the theorem says if a line is parallel to one side of a triangle, and intersects the other 2 sides, then it divides the sides into segments of proportional lengths. So the very first thing that you have to understand is what I am showing you does not work if we do not have parallel lines. What I am showing you does not work if we do not have parallel lines. Okay, so I just wrote out, you can copy this down real quick, but this is if we have parallel lines, then this is what the triangle proportionality theorem says. This segment is represented by A, this segment's represented by B. Instead of using the letters, which you do need to see the letters because on the EOC, they're going to be giving you proportions with the letters and asking you if it's true. So I am going to write that over here, but I'll do that in just a second. But when you have a problem like this, you're going to put this segment over this segment is equal to this segment over this segment. Now, there are lots of other ways that you can work out this problem. I don't always have to go top over bottom equals top over bottom. Okay, I could also put A over C equals B over D, and I would get the same answer. Do you remember me talking about the means and extremes? Either you can set up your problem vertically or horizontally. Vertically, again, I said A over B equals C over D. Horizontally, I said A over C equals B over D, going left over right, left over right. You can go right over left equals right over left. You can go bottom over top equals bottom over top because I could turn my paper completely upside down and say D over C equals B over A and still get the same answer. So it doesn't matter how your paper's rotated, as long as you are not going across the picture, and you cannot say A over D. You can't do that. So as long as you're going vertically or horizontally, you're always going to set these up correctly. Remember, this theorem only happens when you have these 2 segments parallel to each other. Okay, so just to show you with the variables in here, this is what you need to get used to seeing. Sorry, it's BD over DA equals BE over EC. And when you guys see this on the EOC test, the state test that you take, all this is telling you to do is it's just saying, look at the picture. Look at the picture and see if this makes sense. Because I could rewrite this and put BD over BE is equal to DA over EC, and it's still multiplying the means and it's multiplying the extremes. Okay? All right, we're just going to do a couple problems. All right, so this one, remember, you can turn your paper like this if you always want the parallel lines going horizontally, that's fine. And you can go top over bottom equals top over bottom, or you can go left over right equals left over right, or in any form, right over left, bottom over top, bottom over top. It doesn't matter, okay? So I'm going to look at it the way it is, and as long as you're consistent, you're going to get this right. I'm going to say 14 over 12, so if I went this piece over this piece, I have to say x over 15. We are going to cross multiply, so 12 times x, 14 times 15 is 210. And then divide by 12, and we get 17.5. Is that right? And we're done. Okay. All right, looking at this one, I'm going to go 18 over x equals, and if I went 18 over x, so then I'm really looking at it like this. I went bottom over top, so I have to go bottom over top. equals 21 over 56. All right, again, it's just simple cross multiplying right now. 18 times 51 is 918. Divided by 21 is 43.7. 43.7. You can round any decimals to the tenths place. Okay, so that's what we're doing. All right, now, when you have problems like this, you have two ways you could work out the problem. Really, we have similar triangles. That's why this is in this unit. And this little triangle is similar to the big triangle. So we can use the little piece and the big piece if I wanted to, but it would have to be that little piece. And I haven't really, stressed that with you yet, but I'm just going to stick with the little pieces. I can easily get this little piece by subtracting these two numbers. 55 minus 45 is 10. And once I have those four little pieces, it's just a matter of setting up the problem and working it out. So if I said x over 36, I went top over bottom. I have to equal that to top over bottom. All right, this will be the last one maybe that I work out. You'll do the next one by yourself. 360 divided by 45 gives us 8. Okay, so I want you to do number 4, and I'm going to ask you which answer is correct. Okay, so hopefully you got the 21 right here. 21 plus 6 does add to give you 27. We're not using the 27 in our work. I went 7 over x, so I have to put 6 over 21. And then I cross multiplied, and my answer is 24.5. Okay, you are going to have some polynomials. I feel no reason why you shouldn't be able to do this problem by yourself as well. So go ahead, set this one up. Do number 5 by yourself. Okay, you should get x equals 11 for that answer. So we're cross multiplying, and be sure you distribute when you multiply by the binomial. You should have had plenty of practice with that with the extra review sheet that I gave you. So cross multiply, solve for x. Now I want to go over something. Anytime you're working a problem and you see a fraction that reduces, because we're dealing with scale factors and ratios, you can reduce to make your problem easier to where you don't have to pick up your calculator. I know 5 goes into 25 5 times, 5 goes into 15 3 times. If I had multiplied with those numbers, it would be a lot easier. I wouldn't even have to think about using my calculator, which gets me through the problem quicker. I would show you get the same answer. 3 times 30 is 90. And then multiply this way, 5 times x is 5x, 5 times 7 is 35. And so if we subtract, I think we get 55. And then divide by 5, you get x equals 11. Oops, 11. So anytime that happens, you can reduce those fractions. Here's a little tip. Well, we're just going to stick with that. Okay, we're going to skip number 6 and go on to the next theorem. Okay, we're also going to skip these up here. Let me just go over one of these with you. If I was going to use the converse of the theorem, you don't have any of these on your worksheet. I don't believe you could. I haven't looked fully at the worksheet, but I don't think you do. But if I was using the converse, I would have to show that A over B equals C over D. So just to show you that, we would say 11 over 15.4 would have to equal 10 over 14. All you do is you just cross multiply. 11 times 14 gives me 154. And then 10 times 15.4 gives me the same thing. So that means, yes, these are parallel. If these two numbers did not equal each other, then the answer would be no. Okay, so that is the converse. That should make perfectly good sense to you because we've dealt with converse theorems before. Okay, the next one is the proportional parts in parallel lines with parallel lines. So this says if 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionally. Same exact formula. I'm not even going to do a bunch of these examples. I'm just going to talk to you about how you would set them up. Okay, so this one would set up 45 over 18 equals 52 over x. That's one of the ways you could set it up. Okay, this one, just to show you what we could be different, I could say 30 over x equals 12 over 14. I'm not going to work these out right now. I'm going to pick one of these down here for you to work. It's the same thing. Okay, my question is, what number would we put right here? Okay, so we would take 32 and we would subtract 18. 32 minus 18 gives us 14. So we would use a 14 and not the 32. Okay, and you could say 27 over 18 equals x over 14. You could say x over 27. Some people always like their x to be on in the numerator of the problem. X over 27 equals 14 over 18. Lots of different ways you could set that problem up. Okay, so I want you to do number 13. Give me the answer. Okay, here's your answer. You should have gotten x equals 72. You can see my setup. I put 28 over 64 equals 31.5 over x. Cross multiplied, x equals 72. All right, I don't feel the need to do any of these others. It is that easy. Okay, next we have what's called the triangle angle bisector theorem. I want you to notice up here, when you see this marking right here, they're not just marking the whole angle. What they're doing is they are marking that these two angles are congruent and angle B has been bisected. So if BD is a bisector, meaning we have an angle bisector, then it separates the segment in the bottom into two segments that are proportional to the lengths of the other two sides. In other words, if I label this ABCD, it's the same formula. A over B equals C over D. A over C equals B over D. Okay, so let me set up a problem for you. So I'm going to say for number 6, and remember, it tells us KM represents an angle bisector. So that's why you're not seeing it in the picture, but this is an angle bisector. That's how we're able to do this. Remember, you can go vertically over vertical, vertical over vertical, or horizontal over horizontal, forward, backwards. As long as you're consistent, you're going to get these right. So I went 12 over 4.8 equals 18 over x. Cross multiply. 18 times 4.8 is 86.4, and divide that by 12, and we get 7.2. There really is not a way to check your answers unless you put 7.2 here, and then you cross multiplied and you got the same number like I did right here. Okay, in all of these problems, that's really the only way that you could check your work, is to put the number into the problem, into your proportion, cross multiply, and see if you get the same values. But you have to be confident in your setup. Okay, so number 7, I want you to go ahead and set that one up and work it out for me. Okay, you should have got 48.6. And I did the problem just to remind you that if you see a fraction that reduces, you can go ahead and reduce that fraction. And then I multiplied 10 times x and 9 times 54 and got the same answer. Again, you don't have to do that. That is just a suggestion. Okay. Question number 8. My question to you is, what number goes right here? Okay, so the way we get that is, I want you to listen to what I'm getting ready to tell you. It is the bigger segment minus the smaller segment. So 39 minus 15, 39 minus 15 is 24. So I would set up this problem with 24. I'm not going to work it out. If I put x over 36, just to show you that I can do lots of different things with these problems, then I would put 15 over 34. Or 24, excuse me. Okay, and I'm not going to work that out because it is not difficult. All right, I'm going to do number 10, and then you're going to go back and do number 9 for me. So number 10, no, I'm going to do number 9, and then I'll let you do number 10. Okay, number 9. I want you to pay attention to what I told you over here. The way we got the 24 was we took 39 and subtracted 15. So if I have a problem like this, I cannot use this big piece. I have to have the little piece. It is going to be represented by an expression like these. Okay, and it's always what's on the outside, the bigger segment minus the smaller segment. So this is going to be x minus 12. If I were to add these two segments together, what would it give you? X. So I could put 12 over 18 equals x minus 12 over 30. And I can cross multiply. I don't want to multiply by those big numbers. 6 goes into 12 2 times. 6 goes into 18 3 times. That's a lot easier to work with. So 2 times 30 is 60. 3 distribute. 3x minus 36. Add 36. Divide by 3. And you get x equals 32. Okay. All right, just one last problem. Go ahead and do number 10 for me and solve for x. Okay, so you should have got x equals 17 for your answer. I put 3x minus 9 over 27, x plus 11 over 18. And if you set it up differently, our means and our extremes, which one is the means, which one is the extremes? Remember? Means is the middle. Extremes is the edge, okay? So this is your extremes, this is your means. So if we set it up differently, we should still be multiplying the means and extremes. This is what I was going to tell you a little while ago, and I said I'll just wait. So remember what I did here. I could reduce these numbers and make smaller numbers in my problem. You can also do that once you get your problem set up if you have numbers on the bottom that can be simplified or the top. So I just want to show you. What goes into 27 and 18? 9. Okay, so 9 goes into both of those. And it's all about how we get the scale factor from the similar triangles. That's what this is getting to. So 3 goes into 9 goes into 27 3 times, 9 goes into 18 2 times. Then that problem would have been super easy to do in your head and not grab your calculator. So let's do it. 2 times 3 is 6x, 2 times 9 is 18, 3 times x is 3x, 3 times 11 is 33, subtract, add, 33, 43, 44, 5, 6, 51, and then divide by 3. Make sure it's the same answer. 3 times 7 is 20. Yep, that gives you 51. So you could have done the problem without picking up your calculator if you had those small numbers. Just a little heads up that you can do that. Okay, and then I have to add that your worksheets in this is a standard set of notes. The worksheets that you have might have quadratics where you have to cross multiply and then factor to get your answers. And it could have systems of equations. I don't see systems of equations happening in these problems, but I do see quadratics. So just know at any time they can pop up. Okay, thanks, students.